Yes, I am Fred Asibe, your subject teacher. In today's lesson, I'll be teaching on a topic called circle. Yes, you heard me. I'll be teaching on a topic called circle. But before I proceed, I want us to know the objective of today's lesson. Now, the objective of today's lesson is that at the end of this lesson, you should be able to define circle. You should be able to identify parts of a circle. You should be able to divide the circumference of a circle into 12 equal parts. Yes, let me come again with the past objective of today's lesson. Now, in the objective of today's lesson, I said at the end of today's lesson, you should be able to define a circle and also identify parts of a circle and also to divide a circumference of a given circle into 12 equal parts. Now, let's proceed. Now, let's know what a circle is. A circle is a plane figure bounded by a curved line. A circle is a plane figure bounded by a curved line called circumference. I hope you got me right. Let me define it again. A circle is a plane figure bounded by a curved line called circumference. Now, for instance, if I have this as a circle, let's draw a circle of 4 centimeters, of radius of 4 centimeters. Now, suppose we have to draw a circle of 4 centimeters. This is 4 centimeters. The 4 centimeters. When you look at the 4 centimeters, it should be a distance from this point here to this point. Okay, we can extend it. Let's make it as big as it is because we just want everything to be visible. Okay, let's take our radius from radius as 5 centimeters. Now this is 5 centimeters. From the 0 cm to 5 is what we call 5 centimeter radius. Now center this at the center of your center this compass at this point in the drawing paper. Draw a circle. This is the radius. Remember I told you that from here to here is 5 cm. So this is 5 cm. I hope you're all seeing it, students. Yes. Now, if this is 5 cm, now draw a circle round. I hope you're seeing it. Remember what I told you about the compass. The compass is used in drawing circles. An arc. Yes, of different diameters. So this is a circle of radius 5 cm. I know you should know that radius is the center from the center here to any point in circumference. So that is exactly. Now this is a circle. Now if you look at this circle, which has its centers, this point, you can take note of the center. Very, very important. You can call it center 0. You can call this point center 0. Now, if this is the circle, I earlier told you that a circle is a plane figure. This is a plane figure bounded by a curved line. The curved line is called what? Circumference. So that was, you can call this circumference. This is circumference. Circumference. Yes, this is what we call circumference. Circumference. Now, if this is the circumference, this curved line is what we call the word circumference. So that's why we now say a circle is a plane figure bounded by a curved line called circumference. Now, from the center of this circle, O to any point in the circumference are at equidistance. So what it means is that from the center here to any point in the circumference, they are equal distance. And that's what we call the radius. They are at a what? Equidistance. So this is just a good example of a circle, of which everyone here can draw a circle, just using your compass. Yes, I center it. Remember I centered it here. I draw a cyclic shape, which is called a circle. So I now told you that a circle is a plane figure bounded by this curved line we called the circumference. Now, let's look at the circle in details. Now remember I told you from the center of this circle to any point in the circumference, that's from the center here to any point on the circumference, we call the circumference. This curved line we call the circumference. That it's equidistance. Equidistance simply means it's the same distance from here to center O to here. It's the same distance from here to here. It's also from here to this point. It's also from here to here. So that's what we mean by equidistance. Now, the circle, as we all know, has a total of 360 degrees, which is equal to 4 right angles. Yes, what I mean by that is that angle at a point, of course, all of us know is 360. So if you divide this circle into 4 equal parts, it is just going to be 90 plus 90 plus 90 plus 90, which gives you what? 360 degrees. So that's why I told you that a circle has a total of 360 degrees angle, which is equal to the 4 right angle. 4 right angle means you add 90, that is 4. So that's exactly what it is. Now, having known what a circle is, the definition of circle, now I want to look at the parts of a circle. Now, a circle has different parts. Now, the following are the parts of a circle. Now, let's also look at the parts of a circle. Now, the parts of a circle include what we call the diameter. Diameter, yes, you heard me, diameter. We also have what's called diameter when you draw a line. Let's say, for instance, you draw a line from the center. Some of you will be asking me what diameter is. Don't worry, I'm going to tell you what diameter is. When you draw a line from the center to this point, you can call this diameter. Yes, it's passing from the center. Remember, this is a place where we center the compass, right? Yeah, then you now draw the circle. So any line drawn through this point, any straight line drawn through the center of this circle, which meets the circumference at both ends. You see it is drawn from this point to this point at both ends. It's between the circumference. Remember the circumference, this is the circumference. So any line drawn from this end to this end to meet the circumference, that line is called diameter. That straight line is called diameter. So any straight line drawn through the center of a circle, or through the center of the circle, to meet the circle at both ends, that line or that straight line is called diameter. So that's exactly what a diameter is all about. You can decide to call it A, you can call here A, you can call this point B, because it's a straight line. Remember the way we used to draw straight line? We've been doing it. You can just draw a straight line and do it. Just call it straight line. But what actually makes it the diameter, I'm telling you, diameter, let me write it, diameter. What actually makes it diameter is that it's a straight line drawn from point A to point what? B, and it passes through the center of the circle. So that's why I told you a diameter is a straight line drawn through the center of the circle, which means the circumference, at what? Which means the circumference at both ends. It means the circumference at both end. Both ends we are talking about this point A and the point B. So that's what the diameter again. Let me say it once again. A diameter is a straight line drawn through the center of the circle. This is a straight line drawn through the center of the circle. Remember, this is center point O. The center of the circle, drawn through the center of the circle, which means the circumference at both ends. It means this circumference A, both ends A and B. So the straight line means the circumference at both ends A and what? B. So that's what the diameter is. So any line drawn through the center of the circumference to meet the circumference at both ends is called diameter. That's what we call diameter. Now, another part we want to look at is the radius. Yes, you heard me when I said you center the circle at point O and then draw a circle. Yes, this is what's called radius. the distance from the center now to any point where this pencil is, any curved line this pencil is drawing now, is called the radius. That's exactly what we call the radius. Now, when you talk about the radius, what do you think now a radius should be? The radius is a straight line drawn from the center of the circle to any point on the circumference. Remember, I told you again, the radius is the straight line drawn from the center of the circle. This is the center of the circle to any point in the circumference. So this center of the circle to any point in the circumference. That's what a radius is. So you can see I've created a radius. Remember, what was the radius? Remember, I told you the radius was 5 cm. 5 cm is 50 millimeter. So you can see it, measure it. You can see that 5 cm. I hope you're all seeing it. From here now to this point, it's 5 centimeter. So that's what we call radius. So it means that a radius is a straight line. Remember, I told you it's a straight line. This is a straight line. O to B is a straight line drawn from the center O of the circle to meet any point in the circumference. It's not only just center it at B, you can also center at this point, still the same distance. Remember, I told you that from the center to any point in the circumference are equidistant. They are the same distance. Look at it. See, that's the reason why it was able to form this curved line. That's why you see it forming this curved line we call the circumference, because from the center to any point is equal distance. They have equal distance. That's what we call equidistance. So that's exactly what it is. Now let us look at, now having known the radius, now let us look at the segment. Okay, let me label it. This is the radius. So from this point to this point is the radius. Call it radius. Radius of a circle. If there are two lines, maybe from here again to this, we can call it radii. That's the plural of radius is what? Radii. So that's it. So the distance from point O to point B is radius. From the same O to A, once it's you're measuring, taking your measurement from the center to any point in the circumference, they are all called the radius. So that's it. So what it means is that if you bring two radius, sum of two radius can give you a diameter. If this point from 0 here to B is radius, and the same point from 0, which is the center of the circle, to point A on the circumference of the circle, is also radius. It means sum of two radius will give you a diameter. So that's the reason why when you see diameter, they will always tell you diameter is equal to 2 times radius. Yes, 2 times radius. When you times diameter, the radius into 2, you get diameter. So you must add two things to give you a straight line. The two radius is giving us diameter. So if you add the two radius, it will give you diameter, which is like AB. So that's exactly what diameter is all about, and radius. Now let's go to the next other part of a circle. So another part of a circle I want you to know is what we call the segment. Yeah, you heard me, segment. Yeah, some of you will be wondering what is segment. Yes, most times, some of you may have heard the word segment. Now, when you talk about segment, a segment is an area of the circle bounded by an arc and a straight line called chord. Let me come again. A segment is an area of the circle bounded by an arc and a straight line called chord. Now, when you talk about segment, remember from what I just said now, I said it's an area of a circle. This could be a segment, maybe a straight line. Remember I told you a straight line bounded by arc. Yes, some of you will be asking me now what's arc. Arc is just a portion of a circumference. Look at it. If I draw something like this, remember I told you the compass is used in drawing circles and arc. Arc means any small curve you make like this. This arc is a portion, is a part of a circumference. So if I make anything I make from this center of it, anything I draw now is an arc. Once the circle is not complete, it's arc. Yes, let me use that simple word. Once you're drawing a circle and it's not complete, what you have just drawn is an arc. So it's just a curve. Look at it. There's no curve. So from this point, let's assume from this point to this point is an arc. So this is actually what we call segment. This is area. This is another area in the circle. You can call it segment. Let me write it. Segment. Yes, segment. This is what we call segment. This area now, this shaded portion of this circle is called segment. This shaded region is this shaded region, or this shaded portion of the circle, or this area of this circle shaded, is called segment. And remember, I told you a segment is the area of the circle. This is an area. The shaded portion here is the area of the circle. Area of the circle bounded. Bounded means it's being bounded. Is bounded by this or curve. We call the arc, and the straight line we call the chord. I hope you got that now. Let me call the straight line chord. Call this chord, because we will also come into this word called chord. Remember, this is an arc. You can also call this a chord. Yes, chord. Yeah, this is what a chord is. You see, the straight line from this point to this point is a chord. Yes. Remember, I told you again, a segment is the area bounded by an arc. This is a small portion of the circumference now. And a straight line called what? Chord. That's what a segment is all about. Now, having known what a segment is, now most of you will be asking me, sir, what is this chord? Remember, I told you it's a straight line. Now, let me rightly define what a chord is, because it's still part of the circle. Yes, it's still part of the circle. So let's look at the chord itself. Now, the chord is a straight line which joins any two given point on the circumference of a circle. It's a straight line which joins any given points on the circumference of a circle. You see, this is a line now. If you want, you can call it line A, B, C, or I C, D. This line CD now, maybe if you decide, you can call it CD. This line now, this line CD is a chord. So you can see the segment is formed as a result of this arc here, this portion of the circumference here, and this straight line we call the chord. Yeah. So that's why we now say the chord is a straight line which join any two given points. It's joining the two given points on the circumference of a circle. That's what a chord is. So any line that joins any given points on the circumference, they are all called chord. Now, if you look at it, the definition looks very similar to that of the diameter. And someone may rightly ask me, yes, sir, then what is the difference between chord and a diameter? They are all points joining 2 points of the circumference. Now, the difference between a chord and a diameter is that the diameter passes through the center of the circle, but a chord does not. They are all two straight lines touching the points, the end points of a circumference. So that's exactly what a chord is. Now, having known what a chord is, let me redefine it again. A chord is a straight line. This is a straight line CD, which joins any two given points, point C and D, is joining these 2 points on the circumference of this circle. That's exactly what a chord is. So any line that joins 2 points on the given part of this circumference of this buried circle is what we call a chord. So the difference between a chord and a diameter, they are all joining 2 ends of a point of a circumference. It's just that the diameter passes through the center of the circle, while the chord does not pass through the center of the circle. So they are all both joining the 2 ends of the circumference. So that's exactly what a chord is. Now let's look at the next one, another part we call the sector. Yeah, sector. I may decide to draw another radius. Remember, I told you radius is when you draw any straight line from the center of the circle to any point in the circumference. That could be a radius. That is called a radius. Now, from the center of this circle, I may decide also to draw something of this nature. Maybe a line from the center here, O, to the point on the circumference. And remember, there was another one drawn from here. Now, these 2 radius, this is a radius. You see, there are two radius here. One radius is running from this center O to B. Maybe this from center O to E. One is running from 0 to E, and this one is running from 0 to B. Now, if you look at these two things now, something has been formed. Something that looks as if it's triangle or a cone has been formed. But actually, it's not what it is. This is what we call sector. So this portion now is called a sector. So you can highlight it, you can just shade it. Let me shade it. This is all the shaded portion on this circle now is called a sector. So you see, this place I'm shading now is called a sector. A sector is a sector. You can see a sector, and a sector. Now you can see this is what a sector. Are you getting that now? Now this a sector is what called a sector. Now, and I defined a sector. I said a sector is the part of the circle bounded by two radii. Remember I told you the plural of radius is radii. Bounded by two radii and an arc. Remember I told you a portion of a circumference is an arc. You see, I told you here is an arc. Here could also be an arc. So here is also an arc. This is also an arc. They are all arcs. Any just portion of the circumference is just an arc. Now, I now said a sector, from what it is nothing but, a sector is nothing but a part of a circle bounded by two radii. Two radii means two radius. Two radius, this is radius 0E and radius OB, OE and OB. So it's bonded. You see, these radius are bonding this portion I shaded with this what arc. That's what a sector is all about. So it is part of the circle bonded by two radii and arc. So part of the circle that is bonded by two radii and arc is what we call a sector. So that's it. I hope it's clear. So that's what a sector is. So all this shaded portion is called sector. This is an arc, a portion of the circumference. This is a radius. This is also another radius. So bounded by two radius and an arc is what we call a sector. So, but you don't use the word two radius. You can say bounded by radii. Two radii. That's the plural of radius. Bounded by two radii and an arc is what they call sector is all about. Yes, that's it for that sector. Let's look at another part of a circle. Now, another part we want to look at is the quadrant. Yes, you heard me, quadrant. Quadrant. Now, quadrant is nothing but the part of the circle bounded by two radii, which are at right angle to each other and bounded by arc. So you see, the definition I just said now, what I just defined now, it's just like the sector. But it's not actually what it is. This one now, there are two steel radii, two radius, and the arc. But the difference between this sector and the quadrant is just that this time around, you're having two radius making angle 90 degrees. That's what a quadrant is. Just let me draw another line, OF. Let's say this line now is at 90 degrees. This is 90. At the center of the circle now is 90 degrees. This is a radius. This is also a radius. Now remember I told you that from the center of this circle to any points in the circumference are equidistant. Equidistance means they are radius. This is radius. If you measure here now, here is 5 cm. This is also 5 cm. This is also 5 cm. Transfer it with to your meter rule. It's also 5 centimeter. Are you all seeing that now? This is 5 cm. From the center of the circle here is 5 cm. It's equidistance. From the center of the circle here to the circumference is also 5 cm. From the center of this circle to this point in circumference is also 5 cm. So it means they are equidistant. Now we are talking about the quadrant. Now I'm telling you that this portion, can I shade? Let me shade it so that it will be shaded from other ones. This shaded portion now completely. Let me shade it. It's a quadrant. And why do we call it quadrant? Quadrant in this, why it is quadrant is because the two radii meet at right angle. The two radii are meeting at right angle. What it means by meeting at right angle is that they made 90 degrees. That is different between the sector. The sector and the quadrant are almost the same thing because it's about two radii and an arc. So if you look at it properly, you have two radii. Okay, you see the shaded portion now is what we call quadrant. As you can see, this is what we call quadrant. This portion now is called quadrant. Quadrant. Yes. And why is it quadrant? I told you it's a part of a circle bounded by two radii. This is radius 1, radius 2. It's bounded by these two radius. And what? An arc. And not only that, the two radius which they meet at right angle. If you look at the arc is the same thing. The sector, is the same thing with the same definition, is just the same thing. But the difference between the sector and the quadrant is that the quadrant, the two radius meet at right angle, that is at 90 degrees. This here is 90 degrees. 90 degrees. That is the quadrant. That's what we call it quadrant. But here, it should be something less than or more than 90. It shouldn't be 90. That's how you form your sector. So whenever you hear the sector is still the same thing bounded by two radii and an arc. The quadrant is also the same thing bounded by two radius and an arc. But the two radius meet at what? 90 degrees. So that's it for that quadrant. So quadrant again is part of the circle bounded by two radii. 0E. Let's say if I have here E, let us call here F. The radius 0, OF and OB. You see, they meet at right angle with this very arc. Remember I told you a portion of that circumference is an arc, bounded by arc. So that's exactly what a quadrant is. So it's that part of the circle which is bounded by two radii OB and OF, and arc. So that's what a quadrant is. So the difference between quadrants is, if you look at the circles, their definitions are almost just, but it's only one thing that makes the difference, just like we earlier said about chord and the diameter. The difference between chord and diameter, both of them are meeting at the circumference, the two ends of the circumference. But the difference between diameter and the chord is that the chord does not pass through the center of the circle to meet the both ends of the circumference, like CD did. And for that of the diameter passes through the center to meet this. You see, the definitions are always the same, but one thing will differentiate between the two. Just like the sector now, it is bounded by two radii and an arc. But that of the quadrant is also bounded by two radius and an arc, but the two radius meet at 90 degrees. So they form a perpendicular at this point. They make 90 degrees. So that's exactly what a quadrant is. So the quadrant is, as the name implies, is 1/4 of the circle. Yes. What I mean by 1/4 of the circle is that if you divide this 90 to 2, remember angle at a point in circle is 360 degrees. 360 degrees, you can get it by timesing 90 by 4. 490, that's 90 plus 90 plus 90 plus 90 plus another 90 will give you 360 degrees. It's equal to 360 degrees. So if you have 4 quadrants like this, if you form another quadrant here, plus another quadrant here, another quadrant here, some of the angle will give you angle at a point, which is the angle of what? The total angle of a circle has. That's 360. Remember I told you that a circle has a total angle of 360 degrees, which is equal to 4 right angles. So when angles are summed, 90 plus 90 plus 90 plus 90, it will give you 360 degrees. So that's exactly. So what it means is that, as the name implies, quadrant, it implies that it's 1/4 of circle. That's one portion of the, we're talking about one portion of the what? Quadrant. So that's it. So some of the 4 quadrants can give you 360 degrees, which is angle in circle. So that's it. So I think that's it. Yes, now I want to look at the next part of the circle. Now the next part of the circle we want to look at, it's not the last, it's not the least. That's the tangent. Yes, you have heard the word tangent. Now, what do we mean by tangent? A tangent is formed when straight line, which must be at its right angle to the radius, touches the circumference from outside the circle. This one looks as if maybe I'm speaking high grammar. Okay, maybe what it is when we talk about a tangent is formed only when the straight line, for instance, I may decide to draw a straight line now, from this radius, from this point, I may decide to draw a straight line to touch this radius at 90 degrees. A straight line outside the circle. You see, I've drawn a straight line to touch the radius at 90 degrees. If it's touching this radius at 90 degrees at this point, that's exactly what they call a tangent. So what it means now, this is a tangent. Tangent. So when you talk about a tangent is only formed. It's formed when the straight line, which must be at right angle to the radius, touches the circumference at what? 90 degrees. So a tangent is formed when the straight line, which must be at right angle, touches the circumference from the outside circle. You see, this straight line is touching the circle from the outside. It's not inside the circle, though. It should be outside, and it should touch the radius at 90 degrees. It means the angle formed between this radius and this straight line that is outside the circle is 90 degrees. That's when a tangent is formed. So this is exactly what we call a tangent. So whenever you hear a tangent is formed when the straight line, which must be at 90 degrees, it must be at 90 degrees. This straight line now must be at 90 degrees to the radius and must touch the circle circumference from the outside circle. Yes, it must touch the circumference from outside the circle. You can see the straight line is outside the circle. This is inside the circle. The entire here or area here or this portion is inside the circle. Why this straight line is just outside. So that is what we call a tangent. And it's making at 90 degrees. It's meeting at this radius. It's meeting this radius at 90 degrees. So when a straight line, which must be at right angle to the radius, touches the circumference from the outside the circle, that is what we call a tangent. So that's it for tangent for this parts of the circle. So these are details we call parts of circles. So remember, I told you earlier what a segment is, what a chord is, and what a sector is all about, and at the same time the diameter. We also said something about the quadrant and the tangent. These are the different parts of a circle you need to know. So that's it for that part of the circle. Till when next we now meet, we talk about the construction or division of a given circle into a number of 12 equal parts. So that's it.